Okay, class. So on today's agenda, we're going to start talking about inscribed angles. And the definition of an inscribed angle is an angle formed by two chords with the vertex on the circle. That's just a fancy way of saying that the vertex of your angle is on the that the vertex of your angle is on the circumference. Okay, so whereas before the vertexes of our angles were at the center, now they are on the actual circumference. After we talk about that, we're going to talk about arcs and angles formed by secant and tangent lines from a point outside a circle, which are always going to be half the difference. And then we're going to talk about angles formed by intersecting chords, which are always half the sum of their arcs. Okay? Again, those are just fancy way of explaining the rules, and we'll get more into detail into that in a second. And then we're going to work on page 56 and 57, and we're going to work on the questions that are circled, which are going to be 20 in total. Okay? So let's start with an inscribed angle. Here is an inscribed angle. Here we can see I have two chords, and the vertex is on the circumference. I wouldn't worry so much about the two chords part. I would just worry more about the fact that the vertex of the angle is on the circumference. Before, the vertex was on the center, but now the vertex is actually on the circumference. So this is an inscribed angle. Let's take a look at this example here. Here, I have two angles. First of all, this is circle A, and here I have angle DAB, which is a central angle, like we discussed before, because the vertex of angle DAB is at the center. And then I also have angle DCB, or BCD, which is an inscribed angle. How do I know that angle DCB is inscribed? Because the vertex is on the circumference. So let's take a look here and let's calculate the measure of these angles. Well, I know angle DAB is a central angle. And if this arc is 60 degrees, well then this central angle is also going to be 60 degrees. So measure of angle DAB is 60 degrees. But here I have an inscribed angle, which is angle DCB. And the rule for an inscribed angle is that an inscribed angle is half of the arc that it creates. So if this arc here is 60 degrees, then angle DCB, the inscribed angle, is going to be half of that. So it is going to be 30 degrees. And that's our introduction for inscribed angles. We know that central angles are equal to the arc that they create, but inscribed angles are equal to half the arc that they create. Or the arc is always going to be twice the amount of the inscribed angle. Let's take a look at some other examples here. Here, I can see I have a circle here, and I have arc BD, and my arc has an inscribed angle BCD, and if my arc is 80, well then my inscribed angle is going to be 40 degrees. Or if my inscribed angle is 40, then the arc that it creates is going to be 80 degrees. Let's take a look at another example. Again, by the way, notice on letter A here, example A, that the vertex is where? It's on the circumference, and that's the important thing to notice. Angle BCD, its vertex is on the circumference, and that's what makes it an inscribed angle. Let's take a look at choice B here. Example B, excuse me. If you look here, I have angle JKL, and the vertex is on the circumference, it's on the edge of the circle, and arc JK is 100 degrees, so my inscribed angle is going to be half of that. It's going to be 50 degrees. And of course, if they told me that my inscribed angle here is 50 degrees, well then the arc that it creates is going to be twice as big, 100 degrees. Let's take a look at another example. Here, I have arc AB, and I have three inscribed angles to this one arc. So here for arc AB, I have angle AXB, I have an inscribed angle AYB, and I have another inscribed angle AZB. These are three inscribed angles. And you can see that the vertex of all three angles are on the circumference. Well, the rule doesn't change. The rule says that the inscribed angle is half of the arc that it creates. So if this arc here is 50 degrees, well then this inscribed angle here is going to be half of that. It's going to be 25 degrees. So the measure of angle X is 25 degrees. The measure of angle Y, or AYB, is also going to be 25 degrees. And the measure of inscribed angle AZB is also going to be 25 degrees. These three inscribed angles all share the same arc, so all three will be congruent. And all three will be half of that arc. That makes it. Now, let's briefly talk about the next part of our lesson, which are arcs and angles formed by secants and tangents from a point outside a circle are always half the difference. What does that mean exactly? Well, let me show you what that means. Here I have three circles. Here I have three circles. And you can see here that I have secant and tangent lines. This is a secant line here. This is a tangent line there. Here I have two tangent lines, or they could be tangent if they make 90 degrees with the radius, but they're tangent as far as we know right now. And here I have two secant lines. So I can have secants, I can have tangents, or I can have a combination. It doesn't really matter. The point that I want you to focus on is the fact that they have a common point on the outside of the circle. And what the rule says is that this angle is half the difference of the two arcs that create it. So you may not be able to see it here, but let's take a look here. The first one says, here I have arc ABC, which is right here. And in the inside I have arc XYZ, XYC. And if I subtract those two arcs and then divide by 2, it'll give me the measure of this angle. The same thing goes for this arc here. If I have arc ABC and I subtract the interior, the smaller arc here, CDA, between the two tangent lines, if I subtract those two and divide by 2, I'll get this angle here. Same thing with this question here. If I take arc ABC right here, and then I take arc XYZ right here, and I subtract these two, and then divide by 2, I'll get the measure of this angle here. Let's take a look at an example. Here I have a circle with a tangent and a secant line going through it. They told me that arc AC is 178 degrees, and they tell me that arc CH is 102 degrees. So here I have this arc on the outside between the two, between my two lines, and then the little arc in between both of them. So the way that I find X is that I'm going to subtract them, and I'm also going to divide by 2. So let's take a look here. So I have 178, minus 102. It's going to give me 76 degrees, and I'm going to divide by 2, and then it's going to give me 38 degrees. So the measure of angle X here is going to be 38 degrees. Let's take a look at another example. Let's take a look at another example. Here, I have arc CAH, well here's C to A to H, right? Along the two endpoints of those two tangent lines, on the outside of those two endpoints of the tangent lines. Then I have arc CH, which is between them, which is 158 degrees. So this arc out here is 205, this arc in here is 155, and I'm looking for this angle here. And what I'm gonna do is, I'm going to subtract them. I'm going to subtract the big arc on the outside of the lines minus the big little arc inside, and then I'm going to divide by 2. So 205 minus 155 is equal to 50. I'm going to divide by 2, and that's going to give me 25 degrees. So this angle right here is going to be 25 degrees. Let's take a look at another example. Here they tell me that the measure of arc CAH, C to A to H, is 210. And they want to know, oh, and they tell me that this angle here is 62 degrees. So now they're giving me the angle here. They're giving me the angle. They're telling me that this arc out here is 210, and the arc in here, I don't know what it is, and they're telling me that the angle is 62 degrees. Well, in order to solve that, all we need to use is a little bit of algebra. So let's see here, how do I figure this out? Well, I know that if I add 210 plus the arc, the other arc, excuse me, not plus the other arc, what am I talking about? If I take 210, forgive me, because I'm supposed to subtract these two arcs, right? So if I take 210 minus the other arc, and I divide by 2, that's going to give me the angle on the outside, right? If I take these two arcs, if I subtract them and divide by 2, it's going to give me the 62 degrees out here, right? So I just set up an equation here where I did 210 minus the arc that I don't know, divided by 2 is 62 degrees. Well, if you remember, guys, the first thing you want to do in a situation like this is you want to get rid of the denominator. So you multiply the 2 times the 62. So you're going to get 210 minus x is equal to, well, let's take a look here. 62 times 2 is equal to 124. So that's equal to 124, right? That's 124. Now I'm solving for x. So I subtract 210 from both sides, minus 210. That cancels out. I got negative x. And by the way, we know there's a 1 in front of there, right? So now I have 124 minus 210, and that gives me negative 86. So I got divide both sides here by negative 1, and x is equal to 86 degrees. So and then I know that this arc here is going to be equal to 86 degrees. And in this situation, all you want to do is just set up a little algebraic equation. You know that the arc on the outside, or on the outer of the shell, minus the one on the inside, divided by 2, should give you your arc. And if you want to check our answer, well, we can do 210 minus 86 divided by 2, and it should give us 62. So let's do that. 210 minus 86 is equal to 124 divided by 2, and what do we get? The 62 degrees that they told me that this angle was here. Now, what happens when the intersecting lines, what happens when the angles formed by intersecting chords are inside, right? Well, when they're inside, it says that the chords are always half the sum of their arcs. So where before it was the difference, now it's half the sum of their arcs. Let's look at some examples. Here I have a circle, I have arc TE, I have arc G, I have arc GR, and they want to know what is the measure of angle X, which, by the way, this is not a central angle. Okay? Well, here, in order to solve this out, I would add these two arcs and divide by 2. So where before, where my point was outside the circle, I subtract and divide by 2. When my point is inside the circle, I add and divide by 2. So let's take a look at an example here. Here I have arc TG, which is 75 degrees. And here I have arc ER, which is 65 degrees. And I want to know what is the value of this angle here in between both of them, right? Well, since it's inside, I'm going to add and divide by 2. So let's do that. Let's add them and let's divide by 2. So I'm going to take 75 plus 65 is equal to 140 divided by 2. So that's going to give me 70 degrees. So the value of x in this situation here, this angle, which by the way is not a central angle, it may or may not be a central angle, is equal to 70 degrees. Let's take a look at another example here. Here they tell me that the measure of my arc AB is 30 degrees, so I know this arc right here is 30. Hope you can see that. And I know arc CD here is also 25 degrees. Okay? And they want to know, want us to find the measure of angle AEB and the measure of angle CED. So they want these two angles here, which, by the way, these are vertical angles, so they're going to be congruent. Okay? So to find the measure of this angle here, what am I going to do? Well, since my point is inside my circle, I'm going to add these two arcs, and I'm going to divide by 2. So let's see what we get when we do that. So I'm going to take 30 plus 25 is equal to 55 divided by 2, and I get 27.5. So this angle right here is going to be 27.5, and this angle right here is also going to be 27.5, and their vertical angles, which makes sense that they are congruent. And those are the lecture and the notes for intersecting lines inside of a circle, or a point made by two chords inside of a circle, and the point outside of a circle made by two arcs. We know then that an inscribed angle is an angle whose vertex is on the circumference. We know that when we have a secant or a tangent line and the point is outside the circle, it's always half the difference. We subtract and divide by 2. And when our angles are formed by intersecting chords